Hey everyone, so welcome back. What we're going to do today is you and I are going to go on a journey to find the area under an exponential curve. But before that, I just want to revise to you the three types of area under a curve question that you will face in your HSC exam. So the first one I want you to understand or revise with me is an area under the curve with respect to the x-axis. So have a look at this diagram you see on the left-hand side. The diagram here has a y-axis, an x-axis, and this curve, which I randomly just called y equals to fx, I want to label this point. Let's just call it A. And I want to beam it up to the curve. All right? I'm going to label this point here B, and I'm going to beam it up to this curve. So this portion here, starting at A, and if I color this for you, ending at B. If you look at this vertical strip, if it's respect to the x-axis, which is what we're revising, the area that you have is this. And this area is known as the area with respect to the x-axis. It is also sometimes called bounded by the x-axis instead. Now, this area here, I'm just going to label very quickly here for you as capital A. You can find this area simply by using a formula. Easy. Now, this formula here states A is equal to integration A to B y dot dx, where A and B were the borders that I stated here. And I'm going to box this for you. Okay, now the easier way to remember this formula is a little suggestion I say is this. If it's respect to the x-axis, the integral formula will have a dx, and the opposite letter with x will be y. So if that's dx, you opposite letter with x, you just write y. Remember, A and B are just the borders. So that's type 1. Let's have a look here at type 2. Type 2 is an area under a curve with respect to the y-axis. So again, if I could draw your attention to this, this diagram here on the left-hand side bottom corner. Now, again, there's the y-axis, that's the x-axis, that's the curve. I'm going to label this curve y equals to fx again. Now, since it's respect to the y-axis, I'm going to label 2 points. In this case, C, which is on the y-axis, as you can see here, D, which is also on the y-axis here. What I'm going to do is I'm going to beam these 2 points to the curve. Now, when I do that, if you can note this horizontal strip to this portion, starting here at C, ending here at D, right? If this horizontal strip to this curve, the area under this curve to the y-axis here happens to be this area, which I'm going to shade in for you. So this area that I just shaded is known as the area under a curve with respect to the y-axis, also known as the area bounded by the curve and the y-axis. Again, I'm going to call this label, this area, capital A. You can find this area just using a formula. The formula here to find this particular area is equal to integration C to D x dot dy. I want to box that for you. Now, an easy way to remember this is just like here. If it's respect to the y-axis, you write dot dy. If that's dy, the opposite letter is x. So if that's dy, that's x. And then you write C to D. Remember, C to D are the values on the y-axis because it's respect to the y-axis. So in summary, for the first two types of questions you're going to get, you just need to recognize if it's 1 to the x-axis or 2 to the y-axis. If it's x, you write dx. If it's dx, you write y. If it's respect to the y-axis, you write dy. If it's dy, you write x. Those are the two formulas that you will use the most in most area questions. However, in some very, very rare cases, we get questions where you try to use this formula for some reason, you can't use it because you can't integrate it. So if that case ever occurs, you need to think of the third type. And the third type is called methods of shapes. Now, it's hard for me to explain to you methods of shapes. So what I'm going to do is I'm going to show you through examples. So let's get started. So if you have a look here in question number 1, find the area under y equals to ex between x equals to 1 x equals to 2, bounded by the x-axis. Now, a lot of kids, they see the question very clearly. They write out the formula straight away because they know which formula to pick, and they integrate it and the answer just comes out straight away. Look, I don't think that is the way that you should approach these type of questions. I want you to follow how I taught you and have some sort of order and structure. And what is that order and structure? Number one, just like here and here, you draw me a diagram. So let's draw everything that is important here. One, they want you to find the area under this curve, which is an exponential curve. So let's draw that out first. So that's the y-axis, that's the x-axis. This exponential curve is y equals to ex. Now we know that if I let x equals to 0, the y-intercept here is 1. Now they want you to have a look at x equals to 1. Now look at the x-axis, find me 1. That's around here. Right? You don't have to be too accurate. Now, where's 2 on the x-axis? It's around here. If I beam these 2 points vertically to the curve, like so, now, if you look at this portion here of the curve, if they want you to bind or bound or respect to the x-axis, you look at this portion of the curve, starting here, ending there. This vertical strip to that portion, to the x-axis, is referred as this area here I shade in red. Now, I'm going to label this area capital A. Done. That's our first step. What's your second step? You pick me a formula. Guys, there's only 2. So number 1, what are you going to look? You're going to look, hey, what's the key word? The key word is x-axis or y-axis. In this case, it's the x-axis. So if it's the x-axis, you will use this formula because this is the area with respect to the x-axis. And the area formula is equal to integration. It's a to b. Remember, since it's the x-axis, you write at the back dx, and the opposite letter to x is y. Once you write a formula, all you do is you sub what the formula wants you to sub in. Let's try this out. So integration, let's write it out, integral. A, what's that again? It is the first border on the x-axis. In this case, it's 1, right, 1. What's b again? It's the second border on the x-axis. In this case, it's 2. Now you write y dot dx. All right, we have a slight problem. The first thing here is you have a look at integral 1 to 2 with y dot dx. We can't integrate y dot dx. Why is that? Very simple. This is dx, so you want this here to be in terms of x. Because you want everything to be in terms of x if this is dot dx so that you can integrate. This is not. It's y. So what in your mind are you thinking that you should do? You want to change y to x, don't you? So that means in maths, you need a relationship between y and x. So do we see on the diagram or in the content of the question a relationship between y and x? And I can see and I can feel you guys nodding through the camera and saying, there we are. Y is equal to ex is a relationship between y and x. Good, I agree. So I'm going to box this. That's the relationship that I need. So let's give it a go and see if I can sub this into here. You can. Why is that? Because y is already the subject in terms of x. So let's sub it in. Equal to integration 1 to 2. Y here. Ex dot dx. And your last step is to integrate. Guys, to integrate ex, please remember that it's itself. The reason for that is when you dash ex, it's ex. So when you integrate ex, it is itself. Once you finish integrating that, you sub in the borders. Sub in the top one first, so it's e2. Sub in the bottom, e1. Always subtract, and it's in units squared. Okay, so in summary, what did you learn in example or question number 1? What you learned is how to find an area under a curve. In this case, it's an exponential curve. Now, exponential curve bounded by the x-axis. Since it's bounded by the x-axis, you need to remember to use the x-axis formula, which is integral a to b y dot dx. Okay, so that's what you learnt in question number 1. Now, let's have a look here in question number 2 and see the difference between them. Let's read. Find the area between y equals to e2 to the power of x between y is equal to 1, y is equal to 2 with respect to the y-axis. So clearly there is a difference immediately. The difference isn't the curve is different. The difference is that it's respect to the y-axis. So let's see what this difference causes in your working out. Okay, so what is the first step again, guys? What was it? That's right. You draw first for me. So let's draw the y-axis, the x-axis. Next step, you draw the curve, right? So the curve is y is equal to e to x. I'm drawing this for you. I'm going to label it e to x, right? Now, e to x here is that. Now, let me ask you this. If I sub in x equals to 0, e to the power 0 is 1. So that means it cuts the y-axis at 1, right? Okay. Now that my curve is done, I continue to I continue to read the information that's given into the question. It wants you to be between y is equal to 1. So on the y-axis, find me 1. Already done. On the y-axis, find me 2. There we go. They want it respect to the y-axis, meaning they want you to find that area now. So look at 1, which is already there. Look at 2. Beam it to the curve. Oh, it's already there, guys. So you'd have to beam nothing there. 2, you're going to beam to the curve. And it ends there. So if you look at the portion here, starting here to the curve and keep going and ending here at y equals to 2, since it's on the y-axis, when you beam it to the curve, I want you to look at this horizontal strip here. Now the area under this red portion of the curve, horizontally to the y-axis, if you can imagine, is this area in red I drew for you. I'm going to label this capital A. So now you can visually see what area you want. So let's go find this area. What do you do? Step 2, pick a formula. What formula are you going to use? So 1, you say to yourself, okay, what are the two formulas? Here and here. How do I know the difference? Keyword, y-axis. Since it's the y-axis, you need to use the dy formula. In this case, it's formula box number 2. So let's write that formula out. So A is equal to integration c to d dot dy, and that is x. Remember, dy, y-axis, dy opposite letter x, c to d. These numbers belong to the y-axis. So let's go sub everything in and we will integrate. Let's go. So c, first number on the border, it's 1, isn't it? Of the y-axis, it's 1, so write 1. Next border, it ends at 2, so you write 2, again on the y-axis. Now, you write x dot dy. We have now come to a point where we have the same situation as question number 1. You can't integrate x, it's in terms of y. They want it in terms of y because it's dy. All right, we can fix this. If you want x to be in terms of y, x in terms of y, you need in maths what we call a relationship between x and y. So search for me. Read the question. Look at your diagram. Is there a relationship between x and y? And sort of. And the reason why I say this is you have a relationship between y and x, meaning y is the subject in terms of x. So if you want x in terms of y, what does that mean, everybody? You make x the subject for me. So let's make x the subject. To make x the subject, I want to write here e to x is equal to y. Now x is not the subject, you've got to get rid of e. You push the e down, so it's 2x is log e y. Now you make x the subject by making x the subject, by dividing it to 2 over. So it's half log e y. Okay, so now that you have x in terms of y, let's sub it in. So sub this one in. We get integration 1 to 2 half log ey dot dy. Okay, guys, so we have subbed in c and d. We have replaced x in terms of y. It's in dy. We are loving the look of this, this integral, so let's integrate it. But what's our problem? That's right. Guys, we do not know how to integrate logarithms. Because you cannot integrate logarithms, in turn, what does that mean? You can't find this area. So unfortunately, I'm going to call this method 1. It doesn't work. Why? Because you couldn't integrate this formula. But what did I tell you in my mini revision at the beginning? In rare cases, there will be cases where you cannot find the area using these formulas because you cannot integrate. And today, that case has come. So what do you do instead? Method number 3, which in this case, I'm going to call method number 2 because we have 2 methods here. The method 3, or the type 3 question, I should say, is methods of shapes. So how do you do this question? Listen and watch carefully. All right. I want you to look here at 2 on the y-axis for me. I want you to beam it to the curve. There she is, right? I want you to beam now vertically downwards. I want to beam this vertically downward for you, so you guys can listen, please. There. Now, can you all see that when I beam horizontally across, vertically down, I form this box here. Let's call this box a rectangle, shall we? This rectangle here, if you and I went to find this area of this rectangle, that's an overestimation. That would not give me the red area. It's an overestimation of the area. But if you see, this overestimation is not a good thing. But if I deleted this area off and this area here, I'm going to dot here for you so that you guys can visually see what I am referring to. If I delete the dotted area away from the rectangle, don't you get the red area? Let's try that. So we now have a new aim. So aim is equal to, all right, red area, so I'm going to call this red, is equal to, you want to get the rectangle, so I'm just going to go that rec, okay guys, subtract the area of the dots. So I'm going to write here dots, and that will get me or obtain this area that I want. Okay, so let's set off to do this. Number 1, how do you find a rectangle? You need 2 sides, a length and a breadth. Let's try. Do we have this length? Yes, that's 2, but we don't have the breadth. So let's find the breadth by subbing 2 into the curve, which is that here. So sub 2 into here, right? You will get this coordinate as half log E2. All right, so I now have the the length and the breadth, so I can find the rectangle. So let's sub it in. Guys, help me out. 2 times this, so 2 times half is gone. You have here log E2 minus. Okay, we now need to find the area of the dots. So analyze with me, analyze with me. All right, look. This area of these dots, if I'm trying to show you with my fingers, is starting from this portion of the curve, ending this portion here. If you draw a vertical strip to that portion, in respect to this x-axis, don't you get these area of these dots? So vertically up to this curve, respect to this axis, you get the area of the dots. Doesn't that sound familiar? Yeah, it does. That is referring to area under a curve with respect to the x-axis. And we have a formula for that. So we can find this area of these dots. So this is equal to, so now our red area is equal to log E2 minus. Now to do this, we use integration, right? Now remember the formula is this. A to B represents the borders on the x-axis. Do we have that? Yes, we do. 0, half log E2. So we write here 0, half log E2. We write here dx. Why is it dx, everybody? Because it's respect to the x-axis that we want to find, the area of the dots. And you write here y. So it's equal to log E2 minus integral 0, half log E2. Now, do we have y in terms of x? Y in terms of x? Yes, it's right here. So let's sub that one in. So it's E2x dot dx. So it's equal to log E2 minus, what's the integration of E2x? It's E2x. Don't forget the fish. The fish is the number in front of x, which is over 2. Borders, 0, half log E2. So you have integrated that. All we do now is we sub in the borders, and I'm just going to do this quickly. So we have half, so log E2 minus, I'm going to pull out the half first, guys. Now I'm going to sub this into here. What's half times 2? It's gone. Log E2, so what's E log E2? It's 2. Minus, sub in 0 now, so what's E to the power 0? It's 1, so mark that there. And here you have log E2 minus 2 minus 1 is 1 is half. And that is unit squared because it's area. Okay, so now I'm just going to summarize something for you. I want you to remember a few things. How do you find an area under any curve? There are 3 types of questions that they can ask you. Number 1 is if it's respect to the x-axis. If it's respect to the x-axis, It's integration, you write dx, x-axis dx. Opposite letter to x is y, so it's y.dx. Sub in the borders must be long on the x-axis. If the area is respect to the y-axis, then it's integral, you write dy. Opposite letter to y will be x. Then you write c to d, and c to d are the borders, but this time on the y-axis. Don't forget the last method, the last type. The last type is when you have questions where in rare cases you use these formulas and they don't work. If they don't work, I want you to think of methods of shapes. Methods of shapes will require you to see a shape that is an overestimation, like here, and you delete other areas away, like so. And when you delete these areas away from that shape, you will get the area that they want you to find. Now, specifically for this particular curve, exponential, what do you notice? Number one, when you have an area respect to the x-axis, you use this formula, you won't stumble across any issues at all. Like this, respect to x-axis, no problemos. Why is that? Because you can integrate. But when you have a question that happens to make you find the area with respect to the y-axis, right? You have a problemo. What is the problem? The problem is you end up integrating log if it's respect to the y-axis. And to solve that problem, you must use methods of shapes. That there will conclude our mini story on how to find an area under a curve, specifically for an exponential. I hope to see you around in our next video.